When the embryo is 1 week old, it has 2 layers of cells, a dorsal or outer epiblast layer and a ventral or inner hypoblast layer. During week 3 of development, the embryo undergoes gastrulation, where the cells in the epiblast layer form a 3-layered trilaminar disc with an ectoderm, mesoderm, and endoderm layer. So imagine the embryo like a birthday cake with the ectoderm as the candles, the mesoderm as the strawberry frosting, and the delicious cake as the endoderm. We can put 3 candles on this cake to help you remember that gastrulation happens during week 3. If we back up just a bit, around day 15 of development, 2 areas of the ectoderm layer, one in the cranial region and one in the caudal region, push ventrally and fuse with the endoderm layer, excluding the mesoderm layer entirely, and forming 2 bilaminar regions in an otherwise trilaminar disc. The cranial bilaminar region develops into the oropharyngeal membrane, which eventually disintegrates in week 4 to form the opening of the mouth. The caudal bilaminar region develops into the cloacal membrane, which eventually disintegrates in week 7 to form the opening of the anus and genitourinary tracts. During week 4 of development, the embryo folds in 2 directions. In the longitudinal plane, there's a cranial and a caudal fold, so that it ends up looking less like a pancake and more like a little shrimp. At this point, the embryo is just starting to curl into the fetal position. The folding shapes part of the yolk sac into a gut tube, with the remainder of the yolk sac remaining connected not at the cranial or caudal end, but just in the middle. Now, let's switch to the transverse plane, looking at a spot near the middle of our embryo where you can see the yolk sac. In the transverse plane, the lateral plates of the mesoderm split into a dorsal layer called the parietal or somatic mesoderm layer, and a ventral layer called the visceral or splanchnic mesoderm layer. The parietal layer of mesoderm follows the ectoderm and forms the chest wall and abdominal body wall of the embryo. The visceral layer of mesoderm follows the endoderm and forms the gut tube. More specifically, the endoderm becomes the epithelial cell lining of the gastrointestinal tract, while the visceral layer of the mesoderm becomes the muscular wall. The mesoderm also gives rise to serous membranes that become the visceral and parietal pleura. 2 layers of the visceral pleura come together to form the mesentery, which was reclassified as a body organ. The mesentery suspends the gut tube in the abdominal cavity. Meanwhile, the ectoderm and parietal layer of the mesoderm fold around with the 2 sides meeting up and seamlessly coming together in the midline to form the anterior body wall. And this happens everywhere except in the middle where the yolk sac still pouches out. Once that happens, we end up with the gut tube inside the embryo's body. So in a sense, embryonic folding creates a tube inside a tube. Now, the gut tube's divided into 3 regions: the foregut, the midgut, and the hindgut. Once the oropharyngeal membrane breaks down in week 4, the foregut, which includes the pharynx, connects with the mouth, which forms the ectoderm layer. Around week 5, the foregut also gives rise to the trachea and the lungs. The midgut remains connected to the yolk sac, and this connection, which is called the vitelline duct or yolk stalk, gets thinner and thinner over time. The endoderm lines the yolk sac, which sits outside of the body of the developing embryo, so the vitelline duct passes through the umbilical ring to get to the yolk sac. Over time, the yolk sac gets smaller and smaller, and eventually the vitelline duct collapses, and the only remnant that's left behind is the Meckel's diverticulum. Like the oropharyngeal membrane, the cloacal membrane breaks down as well, except it happens around week 7. When that happens, the upper 2/3 of the anal canal, which come from the hindgut, meets up with the lower 1/3 of the anal canal, which comes from the ectoderm. In the adult, the line where they meet is called the pectinate line. One way to remember all this is to think of our cake analogy. When you take a bite of that delicious strawberry birthday cake, you open wide so that it doesn't touch your mouth. And instead, it first touches your pharynx and your esophagus, and it goes all the way through the gastrointestinal tract. But you like it so much that you don't want to poo it out, so it doesn't give rise to the last bit of the gastrointestinal tract, which is below the pectinate line of the anus. The cake can also go down the wrong way, into your trachea, so it also forms the lining of the respiratory tract in the lungs. So, in addition to becoming the epithelial lining of the gastrointestinal tract and the respiratory tract, the endoderm gives rise to the tonsils, the thyroid gland, the parathyroid glands, the thymus, part of the liver, the gallbladder, and the pancreas. To remember this, we can build on the analogy. If you want to digest the cake, you need the help of digestive organs like the pancreas, liver, and gallbladder, so it makes sense that these would be derived from the endoderm. Moreover, if the cake goes down the respiratory tract, it could get stuck on tissue and organs near the trachea, like the tonsils in the throat, the thyroid and parathyroid glands in the neck, and the thymus in the chest. Finally, endoderm cells also form parts of the ear, and the epithelial lining of the urethra and urinary bladder. We can remember this last section by thinking of places where you should never stick cake, like in the ear or in the urethra where it might end up in the bladder. Alright, as a quick recap. When the embryo folds in the longitudinal plane and in the transverse plane, it helps to change the gut tube so that it starts looking like a tube within a tube, with a central vitelline duct attached to the yolk sac in the middle. The endoderm ultimately gives rise to the gastrointestinal tract leading from the pharynx to just above the pectinate line of the anus. It also gives rise to the liver, pancreas, and gallbladder, as well as the respiratory tract, the tonsils, the thyroid, the parathyroid glands, the thymus, parts of the ear, and the lining of the urethra and bladder.